We are gonna learn about cloud platforms in the industry. Cloud computing allows end users and developers to leverage large distributed computing infrastructures. This is made possible thanks to infrastructure management software and distributed computing platforms offering on-demand compute storage and on top of these more advanced services. The three major cloud platforms are Amazon Web Service, Google App Engine, and Microsoft Azure. The first one is Amazon Web Service. It is a platform that allows the development of flexible applications by providing solutions for elastic infrastructure scalability, messaging, and data storage. Compute services. These constitute the fundamental element of cloud computing systems. The fundamental service in this space is Amazon EC2. Amazon EC2 allows developing servers in the form of virtual machines created as instances of a specific image. Images come with a pre-installed operating system and a software stack, and instances can be configured for memory, number of processors, and storage. The description of Amazon Web Service, which uses the service type IaaS, PaaS, and SaaS, that is Infrastructure as Service, Platform as Service, and is a collection of web services that provides developers with compute, storage, and more advanced services. AWS is mostly popular for IaaS services and primarily for its elastic compute services, EC2. The Amazon Elastic Book EBS allows AWS user to provide EC2 instance with persistent storage in the form of volumes that can be mounted at instance startup. They accommodate up to 1 TB of space and are accessed through a block device interface, thus allowing users to format them according to the needs of the instance they are connected to. The content of an EBS volume survives the instance lifecycle and is persisted into S3. EBS volumes can be cloned, used as boot partitions, and constitute durable storage since they rely on S3, and it is possible to take incremental snapshot of their content. Google App Engine is a platform as a service implementation that provides services for developing and hosting scalable web applications. App Engine is essentially a distributed and scalable runtime environment that leverages Google's distributed infrastructure to scale out applications facing a large number of requests by allocating more computing resources. App Engine hosts web application and its primary function is to serve users' requests efficiently. The particular design of application which does not expect any state information to be implicitly maintained between requests to the same application simplifies the work of the infrastructure which can redirect each of the requests to any of the servers hosting the target application. This is basically the architecture of Google App Engine platform, which contains Python SDK, local machine and development. The runtime environment is a major component in the Google App Engine. The runtime environment represents the execution context of application hosted on App Engine. With reference to the App Engine infrastructure code, which is always active and running, the runtime comes into existence when the request handler starts executing and terminates once the handler is completed. Storage is a major component in the Google App Engine. This provides various types of storage which operate differently depending on the viability of the data. There are different levels of storage in memory cache, storage for semi-structured data, and long-term storage for static data. In this section, we describe data store and the use of static file servers. Static file servers are dynamic data, a result of logic application and the interaction with the user. The third one and the most important one is Microsoft Azure. It is a cloud operating system built on top of Microsoft data centers infrastructures and provides developers with a collection of services for building applications with cloud technology. Services range from compute, storage, networking to application connectivity, access control, and business intelligence. Microsoft technologies such as Microsoft Windows Server 2008, SQL Server, and ASP.NET. Azure core components. The Windows Azure platform is made up of a foundation layer and set of developer services that can be used to build scalable applications. These services cover compute, storage, networking, and identity management, which are tied together by middleware called App Fabric. This is basically the Microsoft Windows Azure platform architecture, which comprises of the Windows Azure tools and development tools, App Fabric SDK, Windows Azure platform, and cloud for management portal. There are five components in this: compute, storage, networking, identity, and marketplace. Compute services are the core components of Microsoft Windows Azure, and they are delivered by means of abstraction of roles. Role is a runtime environment that is customized for a specific compute task. Roles are managed by the Azure operating system and are instanced on demand in order to address surges in application demand. The SQL Azure, which is a relational database service hosted on Windows Azure and built on the SQL Server technologies. The server extends the capabilities of SQL Server to the cloud and provides developers with a scalable, highly available, and fault-tolerant relational database. It is fully compatible with the infrastructure and interface export by SQL Server, so applications built for SQL Server can transparently migrate to SQL Azure. This is basically the SQL Azure architecture, which contains of PHP language which is used, SQL Server application tools, and .NET ADO. Thank you.